Hello, hello, hello. So I am going to be starting the stream now. And yeah, the stream is all about, or this workshop, I guess, is all about uh, hacking with hardware. So I'm just gonna help you get started, and even if you don't end up building a hardware hack this weekend, hopefully some of the things you learn from this workshop you will be able to use in future hackathons as well. So let's get started. Um, First thing I want you all to do is head over to walkwe walkwe.com. So this workshop is sort of like, even if you don't have hardware, we can use emulators to emulate arduinos and a few different boards. So if you head over to this site, um, yeah, you basically get a hardware emulator where you can emulate um, popular boards like Arduino Unos, which is what we're going to be doing today. So yeah, hopefully you've all made it by now to walkway.com. I might keep it up there. This might be better, hopefully. There we go. Okay, so you all have to head to this site and then click on Arduino Uno. That should be the first board you see. So if I share my screen, okay, there we go. This should be it. So uh wait, that okay, I'll just go back to that screen. I think it okay, yeah, there we go. So now I can go to Arduino Uno. And hopefully this setup is fine. Hopefully you can see everything. Just let me know in chat if it's not. um so yeah, this is basically your Arduino Uno board, and that's what we're going to be working with today. First I am going to be I am going to be just showing you the basics, how to use LEDs and how to sort of switch on and off LEDs or get them to blink, and sort of that basic stuff. And then by the end of this workshop, we'll see how you can take sensor input from the Arduino, and through some if conditions and other conditions, you can do different outputs based on the input of your sensor. So first off, this is what the setup is. You first get this file called a sketch.ini. This is basically the code that your Arduino will be running. There's also a diagram .json where you can edit some parts, but that's not that important for this workshop. That basically means, like, if you want to change the Arduino's properties, the simulated Arduino's properties, you can do that, but that's fine. And you also have a library installer, but this, I think, Walkway, this platform, automatically installs libraries, which you'll get later, which is why I chose this simulator. Of course, everything I'm doing here you can do digitally as well. I mean, you can do it with a physical board as well. I just thought this would be easy, since even if you don't have an Arduino, you can easily sort of get started and work with a bunch of parts that Walkway already offers, which is what I am getting to right now, which is the plus button. You can click on Add, and just the first option, LED, and here we get an LED. We can delete it, we can flip it, which I'm probably not going to do. um, and we can change the color. So if we have red, we can have green LED, a blue LED. I think I'll go for a white LED. And I think this longer uh, pin is the positive, and the shorter pin is the negative. So basically, in the Arduino, the two most important slots are, I guess, this 5-volt slot, like the 3 and 5 volt slots. You can see these here, and that's what basically supplies power. These are the input slots, basically input or output slots. Like, for example, if you're controlling a servo motor, or if you're controlling an LED, like in this case, you would use some of these slots, and these are all a bit different, which Is a little more complex, and I won't be covering in this workshop. But if you are interested, you can look it up. What the different uh, pins do. This is sort of analog input, and a lot of sensors use that. And then these two pins are the ground pins, and that's basically the negative of the Arduino. So for a circuit, you need like some positive stuff and some negative stuff. Some of that. So you will be doing that. You will need these few things. Okay, so I'm going to wire this up to I think 5 volts. This pin, and I'm going to wire ground to, and you can just click to make wires. So there we go. Okay, but what's now if I run the simulation, nothing will happen, obviously. Um, oh, sorry, wait. I wasn't supposed to do it on the 5 volt. Sorry, let me just stop the simulation. This might be where you get your power from, but we are actually going to wire this to pin number 13. Uh, and pin number 13 is basically like just one of the output pins, and we can wire the LED to that and control it through that. So now we get to the code part. Hopefully, you guys have done that. So now I will get to the code part. Um, so what we have to do first is we have to define the LED pin so that the Arduino knows where the LED pin is, obviously. So I will, and the way to do that is you have to do hashtag define LED or whatever name you want to give it, and then so it's basically define, and then this is the name you want to give it, and then the value. So the value is 13, and the LED pin is 13. Then what we want to do is in our setup. So here we have two automatically built-in functions, right? We have void setup and void loop. So void setup or setup just is a method that runs as the Arduino is run like for the first time, and the code here will run once. But your void loop will run repeatedly, so which is obviously just a loop. Um, so in our setup, we have to just give me a second. Sorry, I had something pinned and it's not okay. There we go. Okay, so then we have to define what sort of mode the pin is. So we can have either input or output for this pin, and since we're controlling the LED, we're sending basically a signal to the LED. We will need to define this as an output pin. So that we can do in setup, where we can write pin mode. Wait, it should be 13, I think. No, okay. Pin mode LED 13. I'm sorry, no, not 13. LED and input. So basically, what you're doing is you're setting the the LED to an input to an input mode, basically. And obviously, you have to not forget the semicolon. Um, oh, I wrote input. Whoops, I meant output. Output. Okay, so there we go. So now it's set to an output mode. Uh, Next, in void loop, what we need to do is we need to write. We basically need to switch on this LED, right? And the way to do that is you have to write digital write and LED high. So a high state is basically um a state of like any output device, like any simple output device like an LED, can either which can be either on or off. So high basically means it's on and low basically means it's off. So now if we run this code, I don't think anything is happening, which is something I want to get to. uh so basically what's happening here is that the LED's input voltage is really low, but the output voltage of pin 13 is comparatively much higher. So we will need to do some simple maths, but that maths can just be, you know, you can just Google that sort of stuff if you're following a tutorial or something, which I recommend. So I'm just gonna delete this wire here. You can go ahead and delete that if you just click on the wire and press delete. And I am going to add a new part, a resistor. So to limit the current that we're getting from pin 13, sorry, the current or the voltage that we're getting from pin 13, we need a resistor to sort of reduce that, so that the LED can work properly. And now if we wire this LED up and this, and since we have this resistor's default value is set to 1000, I think, and we can check that in diagrams.json. So that means it's 1000 ohms of resistance. But actually, what we need for our value of resistance is 220 ohms. So you can go on to diagram.json, find your resistor, and change the value to 220. And that means that this resistor now has a value of 220. So now, hopefully, if we run this, it is it working? This should. Oh, I may have wired this wrong. This is supposed to be positive, and I may have wired it to uh, the ground. So I'm just gonna delete this wire. How can I? There we go. Delete this wire, and I will delete this wire, and then take the long wire over there and the short length of the LED to here. And now, there we go. You can see that it's working. Uh, so yeah, you do have to be a bit careful about that. Basically, the long pin is always positive, and the short pin is always negative. The right, yeah, it does. Uh, so yeah, that's basically how you can get a basic LED to work. But then, let's say we wanted to blink, to just turn on and off. So you might think that we can just go on to loop, and we have to say digital right LED low, and this should hopefully work, right? Because we're just switching it on and we're switching it off in a loop. But if we switch it on now, it's just on. It's not doing what we want it to do. And the reason for that is that sort of the rate at which the Arduino sends signals is way too fast, and we just get an LED that's just on. And to sort of solve that issue, we need to learn about one more function, which is the delay function. So the delay function basically takes this value in these parentheses, and it delays the program, the whatever code is below it, by the number of milliseconds. So let's say we want it to delay for 1 second, and we need to obviously have it off for 1 second as well. So hopefully now, as this loops, it'll switch on. It'll delay for 1 second, so it'll be on for 1 second. Then it'll be off, and then it'll be off for 1 second. So now if we start the simulation, there we go. So it's going on and off every 1 second. Okay. So now that we've made an LED blink, we can tackle probably a bit of a more complex project. And I thought this was an interesting thing, because of our summer theme. So what we're going to be doing is we're going to be taking the temperature from a temperature sensor, and depending on the temperature that we get, we have to switch on different LEDs. So for example, if it's very hot, we can switch on the red LED, or if it's very cold, we can switch on a blue LED, or if it's a nice weather, then we can switch on the green LED. So now I will just share this that I have made. Okay, my face is really big now. Uh, Let me just share the new tab. There we go. Okay, so now hopefully you can see this. Yes. And this code we'll get to later, but basically what I've wired, oops, I will just remove this first. What I've wired is I've added a new sensor called a DHT22. So if you go into your add button now, you can type in DHT22 and click on that to add it to your circuit. Then here you can see the different pins, and that's a great thing that Walkway does, which is that you can see all of the different values. So ground goes to ground, and VCC goes to 5 volts, and SDA will go to the output pin, which we are going to wire to the seventh pin. So yeah, if you could go ahead and do that. So remember, wire VCC to 5 volts, wire this SDA to 7 volt, to pin 7, and wire this ground pin to ground on yeah, to ground on the Uno, and I've been using ground 1 here, so that's another ground pin that you can use. It's closer to this diagram, so I guess it just makes more sense. Somehow the default ohm resistor works for the lighting yeah, so um there's basically like a range, but I think the ideal resistance that should be there for LEDs, at least for like one LED, is about 220 ohms. And I mean, yeah, there is kind of a wide range, but I don't know, a lot of the online community and I have found that 220 ohms is a very common resistor and it works well as well. So but yeah, I guess you could use 1,000 if that works for you. Resistance usually for like different sensors and different output devices is usually like at a sort of a wide range, and you should definitely look that up for your output device that you're using. Okay, so hopefully this is done now. Hopefully you guys have done this now. And then now that you've wired this, you're going to want to write some code. uh, and So first what we're going to do is to work with this sensor. The Arduino doesn't really have built-in support for this sensor, so what we're going to do is we're going to get this library, dht.h, and the way to sort of get this library, or to work with this library, is you have to type in include, and then the less than and greater than signs, and in between that you have to type in the library name .h, and .h is basically the sort of type of the library or whatever. um, and yeah, basically what we want to do is we need to work with the DHT sensor, so we will load the DHT library. And yeah, hopefully you guys have done that by now. And like I said earlier, we need to sort of define some pins. So I've defined the DHT pin as 7. And that's the only pin I have to define because the other one is connected to ground and the other one is connected to 5 volts. We also have to define DHT, or define our DHT22. So we just define that as DHT type DHT22. So basically, like, this library has a bunch of different DHT sensors. Like, there's DHT11, which I've used before, and a few others. So you have to make sure that our program or the Arduino knows that the DHT22 is the sensor we're using. And now we have to create basically a class, a DHT class, where it's where we're running this method, and the DHT sensor is connected to this pin. So we're defining the pin and the type. So we've got DHT22 and 7. Then to work with the DHT sensor, it gives us two values, which is temperature and humidity. So I'm just going to define two variables for this, and we're going to use the data type float to get a more accurate measure. So we've got float temp and float hum. or float temperature and float humidity. And that's what we need to define so far. So I'm just going to give you a couple of seconds to write all of that. Uh, okay, so this is fun. uh, okay, so hopefully you guys have done that by now. Uh, so yeah, next we move on to our setup. And we need to do two things here. Here we need to first do serial.begin 9600. So you'll see a lot of like project. This is basically telling the serial ports to open at a baud rate of 9600. So I don't think it's that important for like a beginner who's just doing a quick hardware hack to learn a lot about this. But it is interesting, and I suggest if you're interested, you look up, what serial.begin does and what 9600 and baud rate is. But yeah, I won't be covering that in this workshop. Uh, the next thing is we're going to begin the DHT sensor. So this basically activates the sensor and it allows us to get, some input. And now we've finally moved on to the loop, but I'm just going to give you 2 seconds to just write the serial.begin 9600 and DHT.begin commands, or I mean functions. Uh, all right. So, in our loop, first we're going to be delaying, which basically means like we're going to try to get the temperature and humidity every 2000 milliseconds or 2 seconds. You can change this to whatever you like. For example, like if I want it, let's say every 10 seconds, I can just write 10,000, but for the sake of this, I might even change it to 1000. And now we've got temperature equals dh. Yeah, so now we're getting the value for temperature, which is we take our variable temp from above and we equate that value to what dht dot read temperature returns, and that's the value of the temperature. So dht sensor detects the temperature using this command, and we get that command. Uh, and we use that function to get the temperature value. And similarly for read humidity, we've got dht dot read humidity, which will give us the humidity value for that 1 second. So hopefully you guys are doing that now. I'll just give you a couple of seconds. Okay, sure. I will continue then. So yeah, what we're going to do then is we're going to use serial dot print, which is basically like the print command for an Arduino, and that basically pops up a window here and outputs whatever you want it to output. For example, if I just wrote serial dot print, it's like any other uh, it's like any other print command in any other language. Uh, yeah, so we're gonna print temperature, the value of the temperature. Then we're going to print line this time so that we get a degrees Celsius as our last thing, and then we move on to a new line. Otherwise, if we just use print, it would just print in all one big line, which is not a good idea. I mean, it's not readable. Um, and yeah, so then we're gonna output the temperature, output degrees Celsius, and then in the new line we're going to output the humidity, which is comes as a percent value. Uh, so yeah, now if we hopefully run the simulation, you can sort of check, or you can write this code as as you're watching this. But I'm just gonna start the simulation, and hopefully it should work first try. Okay, there we go. Yeah. So you can see that the temperature is 24 degrees Celsius, and the humidity is 40%. These are obviously like simulated values, so they might not be like accurate or whatever. But yeah, this is a simulation. So yeah. Uh, but yeah, what we are doing here is we're getting the value and we're outputting it directly. But now, how do we work with that value? So what I'm going to do now is I'm going to add in 3 LEDs. Okay. I'm gonna add in three LEDs, a red one, a green one, and a blue one. So I will add new part, LED. Okay, so we've got a red one, we've got another one. This one can be the green one, and we're going to get a blue one. So this one can be a blue one. And we are also then going to need uh three resistors. So we've got one here, and we've got one here, and we've got one last one here. And we're going to go in the diagram.json, and we are going to change the resistors resistance from 1000 to 220. I know it was working for, like, I know 1000 was working for some of you, but yeah, I am going to be changing it to 220. Okay, now we can uh hopefully it should, okay, there we go. We're gonna flip that, we're gonna flip that, and we're going to flip that to just make our wiring a little less cluttered. And I'm gonna wire this 13th pin to this, and this to this, basically what we were doing last time. And I'm going to wire this to the ground pin. Once again, same thing with the green LED, the positive to the resistor, but this time I'm going to wire it to the 12th pin, and I'll go and do that with the blue LED as well. I'm going to wire that to the 11th pin, and obviously I'm going to get the ground pins on this as well. And this is the last one I have to. Okay, and I think I will probably change the color of these wires so it's a bit easier to understand. But yeah, okay, wait, I can do this, and this is also a ground, so I will do this, and this one is also ground, so I will use black. And this one is the red LED, so I might not use red because that's usually the positive, and I want to make it a bit less confusing. And the green LED can be that, I guess, and the blue wire we will change to blue, just to make it more readable and, not look like an ugly mess. Uh, sure. So now that we have wired this up, this crazy thing, we've got the red LED, the green LED, and the blue LED. And of course, we're gonna define their pins as well. So we've got define LED R for red on pin 13. I'm going to define LED G for green to pin 12, and I'm going to define LED B, just LED blue to 11. Okay. So now that we have that, hopefully we can, if we just do a quick check, we can do digital write. Oh, whoops, I totally forgot about pin mode. So we will have to define the pin mode of all of these LEDs. So we've got LED R output. We've got LED G as an output pin. And we've got LED B as another output pin. Okay. So now we can probably just do a quick test with the digital write LED R comma high. So hopefully too few arguments file included in this. Huh. Too few arguments. Okay. Mm. Oh, this is okay. I accidentally wrote digital right twice. That makes sense. Um, okay, yeah. So this is a DHT22 sensor, as I said earlier, and that is basically used for detecting like the temperature and the humidity, and it outputs temperature as degrees Celsius and humidity as percent. And what we're trying to do right now is we're trying to get the temperature, and if the temperature is too high, then we're gonna do a red LED. If the temperature is, in an acceptable range, we're gonna do a green LED. And if the temperature is very cold, then we're gonna do a blue LED. We're gonna, set that on. And yeah, I will share all of this code and this project as well with all of you. And yeah, hopefully that will help after this workshop. I wouldn't want you to cheat. Okay, so if we just try that now. Oops. There we go. So the red LED is on, which means that this is hopefully wired correctly. So yeah, now what we're gonna do is we're gonna write a series of if statements. This is a normal, obviously a very useful programming thing. So yeah, uh, I would say probably above 35 degrees is kind of hot. So I'm just gonna say if temp, since we already got the temperature value, if temp is greater than 35, uh, and we're gonna use the open brackets, I mean the curly brackets, uh, then we can switch the red pin on. And since we already know the switching the red pin on is digital write LED R, comma high. Okay, but uh, okay, and now let's see uh, else if, and we want another condition, right? So let's say the acceptable range is 35 to I would say maybe 20 degrees, maybe 18 is acceptable. So I'm gonna just say if temperature is greater than 18, and since this is an else if, I don't have to write uh if temperature is less than 35 as well, because we already checked for that. And if the temperature is less than 35, um then it'll automatically go on to here. So we're gonna just check if it's greater than 18. uh and we've got digital write LED G comma high. I'll switch the green LED on. And now we're gonna do our last else if. Or I guess here we could just do else, because we've already checked for every temperature. So else digital write LED B high. Okay, but now there is a problem in my code, which is that let's just run this through our head. So if the temperature is 35, or if it's let's say 42 degrees, right? 42 degrees Celsius. Then this uh, then this red light would switch on. But then if in the same day and while this program is still running, it drops to maybe 25 degrees Celsius, then the red light will also be on and the green light will also be on. So what we can just do here is whenever we're whenever we are oops whenever we check for this, we can just set all pins to low first. So we can set LED R to low. We can set LED G to low, and we can set LED B to low. Okay, now hopefully this should stay on green because it's registering 24 degrees Celsius. And since this temperature is simulated, we might not be able to test for other temperatures. But The way to show that it still works, I would say, is we can do temperature is equal to temperature, let's say plus 20. uh, so now that we do that, the input temperature will be or the final temperature will be 20 plus the initial temperature, and that should hopefully set the green or the red LED to on. So let's do that. There we go. So now the red LED is on. uh and whoops, I will just stop the simulation, and let's say we do minus 20, or let's just minus 50, minus 13. Let's do minus 20. um Now if we do that and we start the simulation again, yeah, there we go, the blue LED is there because it's registering 4 degrees Celsius. To test that our system for switching off the LEDs still works, and like changing the LEDs, I will do a delay 2000, and I will do, or let's say 3000, and we will do temperature equals temperature plus 40, let's say. And I'll offset the 20 and add 20. So let's say it starts, it's going to be blue. And when it checks the temperature again, oh right, of course, what am I doing? It's checking the temperature here as well, right? So we will uh we can just copy this. It looks really ugly, but we can just test that this whole thing is working. I guess we can copy this as well. This looks very bad, but this is just a test, if our code is working, so that seems fine. Yeah, there you go. Now hopefully it's going to be blue first, and then it's going to register as red. Yeah, there we go, and then blue and then red, because the temperature keeps on flip-flopping. And if we just remove this minus 20 here, it'll go from, I think, green to red, hopefully. If we just do this, there we go, so it's green, and then when it gets the new input, it's red. So there you go, that works, which I'm very happy with. And we can delete this because we don't want this again. But yeah, I think this should be the end of the workshop. I have shown you how to wire 3 LEDs, do a few of the LED blinking and stuff. And we've worked with the DHT22 sensor as well. Hopefully this was informative. If you have any questions, you can put them in chat and I will be happy to answer them. I'm just going to leave this up here in case somebody wants to take, a screenshot of the board, or like of the code. But I will share that later anyways. So yeah, I'm just going to wait around for a couple of minutes in case there are questions. And I will take a picture of this stream for my Twitter. There you go. Say cheese, guys. Okay. My camera's lagging. There we go. Okay. You have all been immortalized on my Twitter, which is at ender_Arno. Yeah. You should definitely follow that. Best Twitter ever to exist. Ever. Okay. I'm just going to wait for, I think, 1 more minute in case there are questions, and I'll be ending the stream. Oh, and you can definitely ask about like resources and stuff. There are a ton of great websites for Arduino, including like, I think, Arduino makers, or yeah, and they have a ton of like good guides online. So I mean, it's like working with an Arduino is exactly like coding, because you're not really expected to know everything. You're just like, half the time you're just googling stuff, maybe more than half the time. But yeah. And yeah, hardware is definitely really fun. So if you would ever like to work with hardware, I would highly recommend it, because I think like the magic of like making something, uh that works both like through code and through like hardware, like two media, it just feels like awesome. Especially because there's a lot of debugging involved. Yeah, like and you can do pretty much anything with hardware. Like I made I think I made like a couple of past projects using hardware for hackathons, and every time it was just really fun. So I would definitely encourage you to try hardware sometime in your life. Okay, I see there are no more questions, so I will now be ending the stream. Thank you all for coming, and yeah, hopefully you learned something, and hopefully you had a good time. Okay, bye guys.